Your learning intention for today is I'm learning how to add fractions with different denominators. Your success criteria is I know how to manipulate my fractions so that they have the same denominator and I can add properly. Before we actually jump into numbers and the process of this all, I want to discuss some vocabulary with you guys. First of all, what is a denominator? Well, you know how in a fraction you have a number at the top and a number at the bottom? This top number of the fraction is called the numerator, and the bottom number is called the denominator. And that's going to be really important for you to know because we're going to be turning both our numerators and denominators and changing them so that you're able to add properly. Now, my next question, or the question that you may have, is why do you need to have the same denominator when you add fractions? Well, that's a very good question. Let's not even think about math for a second, and let's say I had some M&Ms and I had some jelly beans. If I have two M&Ms and I have two jelly beans, and I were to add them together, does that mean I have 4 jelly beans? No, they're two different pieces or two different kinds of candy. This is the same thing with fractions. You can't add half pieces, which are big and chunky like this, and then little tenths, and then say that you have however many pieces, because they're not the same size. They're not the same unit. Another word that I would use when we are still having in-person instruction is pieces. I would ask you guys, I would go like this: what kind of pieces, what kind of pieces, right? So you can think of it as pieces, what kind of pieces, or you can think of it as, or the more mathematical term is units. You need to have the same type of pieces, you need to have the same type of units. Those are just some lingo or words that I'll throw around with you guys, but they basically mean the same thing. Alrighty, let's hop into the math. And here we have 2/3 plus 3/5. The reason why I have these pictures here is because this is going to be the 2/3 drawn, and this is going to be the 3/5 drawn, and then we're going to manipulate our denominators on this side. Okay, let's start off with 2/3. I'm gonna, specifically for this method or strategy, I'm gonna write my pieces with vertical lines. Vertical means up and down. So here are my thirds. Ta-da! And then over here, I'm gonna use horizontal lines. So that means left to right. 1, 2, 3. Let me try again. Okay. 1, 2, 3. Perfect. Okay, so starting off with 2/3, I'm gonna grab a different colored marker and color in 2 of these. 1, 2. Awesome. Over here, 3/5. So I'm going to color in 3 of these. 1, 2, 3. Perfect. Now, can we add these thirds with the fifths when they look just like this? No, because as you can see, these thirds are a lot bigger than these fifths. So you can't combine them. They're not the same type of pieces. So I'm actually going to draw the same exact picture over here on the bottom, and then we're going to do a real cool trick that I don't know if you've learned already, but if you have, then this will be review. Okay. 1, 2, 3. 1, 2, 4, 5. Awesome. Okay. So here we have the same pictures drawn on the bottom, and now I need to color the pieces just like so. Yeah. 1, 2, and 3. Awesome. Now, what I'm going to do is imagine I can peel this picture off and place it on top of here. So these have vertical lines. I'm actually going to draw these lines on top of here. And then for these lines, I'm going to do the opposite. I'm going to go up and down. So let's see, I have 1, 2, 3, 4 lines so that I can make 5 pieces. I'm going to do the same thing over here. 1, 2, 3, 4, 5. Awesome. So now I have a cool grid that looks like this. Oh, they're starting to look the same, right? So now the lines that these are missing are these horizontal pieces. So I have 2 of them right here, 1 and 2. I'm going to put them over here. Breaking this down into thirds. Ta-da! Now let me ask you guys, do these pieces look the same as these pieces? Yes, we now all have the same sized pieces. Now I'm going to see how many of these smaller sized pieces that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these pieces. How many in total? What kind of size pieces do I have? So I would have to count all these pieces. So I have 10, 11, 12, 13, 14, 15. Awesome. I just turned my thirds into 15ths. So now I'm going to come over here to this side. I can put 15 on the bottom again because I know that these are 15th size pieces. And now I'm going to count my colored in pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome. Now we can add them together. But before we go into that, I want you to just take a good look at this and notice how my pieces, even though I manipulated them and just basically changed them into small pieces, they're still representing 2/3. 2/3 is still the same as 10/5. It's just sliced up differently. Same thing with 3/5. 3/5 is the same exact thing as 9/15. See, the same amount is still colored in within these pictures. The only difference is now I have teeny tinier pieces. I have 15th size pieces. Now I can add these together. And doop, doop. Well, on the bottom, that's going to tell me what kind of pieces I have. And I have 15ths, right? And then now we can add the pieces on the top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I'm adding the 10 pieces and the 9 pieces. So now I have 19 15th size pieces, or 19 15ths. Now, when you look at the number over here, how did we go from thirds, taking a look at this denominator, to 15ths? What number did I have to multiply 3 by? Think about it. All right. I multiplied it by 5. Because 3 times 5 is 15. Now, how about 10? How did I get to 10? How did I go from 2 to 10? What did I multiply by? Same thing. 5. Whatever you do to the top, you must do to the bottom in this case. But now with this number 5, where in the world did this number 5 come from? Do you see this number 5? Where else do you see it besides over here? I actually got it from this denominator. Ta-da! This got scooted over here. Just a little pattern for you. Now, over here on this side, how did I go from 5 to 15? 5 times what equals 15? I actually multiplied it by 3. And how did I go from 3 on my numerator over here to 9? Well, same thing. Whatever we did to the bottom, we had to do that to the top. And I multiplied it by 3. Now, where else do you see this 3? Da-da-da-da-da-da-da-da. Actually, from the other fraction. And that is another strategy that got us to the same size pieces. Ta-da! Awesome. Okay, time for your practice problem. Now, when you do this problem, I want you to show your work just like this. So have the 2 fractions that I'm going to give you. Draw your rectangles. And then start off with vertical lined pieces and then horizontal lined pieces. And then after that, you're going to mix them up together on both sides. And then, because I really want to be able to see your pictures as well. And then later on, once you get more comfortable with it, then you can use this strategy of multiplying the denominators of the different fractions across with each other. Alrighty, here is your practice problem. I want you to show me 1/3 plus 2/5. And I'll even draw your rectangles for you. That way you can show me your work using this template. Here you go, 1/3 plus 2/5. Alrighty, have fun with it, guys.